Okay, so hello everyone. Bonjour à tous. George Gananadis, Ariel Figov, Sarah Gannon, and myself are pleased to have you back or to welcome to this online seminar series on programming in mathematics education. As always, we wish to begin today by acknowledging this land where the Fields Institute for Research in Mathematical Sciences is situated and from where we are hosting this event. For thousands of years, it has been the traditional land of the Huron-Wendat, the Seneca, and most recently, the Mississaugas of the Credit River. To date, this meeting place is still the home to many indigenous people from across Turtle Island, and we are grateful to have the opportunity to be hosting our online seminar series from this land. So as you know, we have, as part of this program, we have 6 seminars. Today we are going to hear about the fourth of this series, so from Chronis Kynigos from Greece. And it's been very interesting and enriching to hear all of these different perspectives that has been shared and discussed with us about programming, or more broadly about computational thinking in mathematics education. So, and from the short discussion we had with Chronis this morning, and reading as well the abstracts for the coming seminars, we are really looking forward to this different additional perspectives that we will hear on the topic. The organizing team would like to invite you to visit the website as we gathered additional resources to this seminar series. In particular, we have there materials for teachers on coding and mathematics that have been selected by our guest speakers, the ones that have already presented. And so as we will continue with the seminar series, you can see these this resource website being further extended. So we welcome you to go visit there. And there's as well related research papers selected by our guest speakers if you would like to extend your experience about these topics that are being shared with us through these seminars. The series is supported in part by funding from the Math Knowledge Network that is hosted at the Fields Institute for Research in Mathematical Sciences and the Social Sciences and Humanities Research Council of Canada. So we're very thankful for this sponsorship to be of the event that makes possible to have this event. On this, I think we're ready to start with today's seminar. After a short introduction of the speaker by my co-host, George, we will hear Chronis talk to us all. Elementary and high school teachers and leaders, graduate, undergraduate students in education, and academics in mathematics education in education. And that will be followed up by a period of questions and finally a short conclusion. George, please.
Thank you, Chantal. Hello, everyone. It's my pleasure to introduce today's speaker, Dr. Chronis Kynigos. Professor Kynigos is the director of the Educational Technology Lab at the National and Kapodistrian University of Athens, Greece. His research focuses on the design of digital media for socio-constructionist learning activities and their use in the context of added value pedagogical methods. Recently, he co-designed and developed MALT2 for mathematical modeling and Choico for socio-scientific gaming. These projects also include Horizon 2020, Educational Robotics for STEM, FP7, Mathematical Creativity Squared, Remath, representing mathematics, and the co-design and development of eSlate, Machine Lab, and CruiseLet. He was also the founder of the Greek Association for Research in Mathematics Education and a member of the steering committee for the Greek Ministry of Education's CTI, the Office Long-Term Teacher Education Initiative. He has been involved in large-scale interventions in mainstream education, focused on the value of design in the context of lifelong learning. With that, it's my pleasure to welcome Chronis Kynigos and for his presentation on designing for mathematics through baking.
Okay, well, thank you very much, George and Chantal, for inviting me to speak and be part of the seminar. I'll share my screen. So, today's talk is titled Designing for Mathematics Through Baking. I'll use the word baking. So some of you who may have heard of my work, you know that I've been working in the idea of getting students to start programming and doing mathematics through programming, starting from models that have been designed and given to them, and they've been designed as faulty, as having a fault, a bug, or something which is not complete, if we could say as incomplete models. So and this is a kind of a structure for students to focus more succinctly on trying to identify what is wrong, try to identify the properties with which these models have been designed and developed, and trying to figure out and think what it means that a property is missing, or that it's superfluous, or what changes need to be made so that the model works properly. But I'm using the word baking not only to express the mathematical activity, but also to provoke that we need, and to make the central argument of my talk, that we need to collectively engage in developing a better, more elaborate and more succinct language for the kind of mathematical activity we're talking about, both internally within the mathematics education community and the community who is following this line of seminars, but also for communicating with people interested in education outside the mathematics education field, especially those who are excited this phase of life with 21st century skills, with the idea of creativity, critical thinking, collaborative learning. All these are buzzwords, computational thinking, that are very prominent today. The question is, where is constructionism? Where is programming and mathematics? And how can we address these communities to explain where we're coming from, and how commensurate and how in line with their thinking is what we're talking about. So, with respect to baking, what are we baking? We're baking models, digital models, yes, and also games. The word usually used for changing games is modding, game modding. The reason I'm using the word baking is that I will be talking about games that are intentionally designed so that something's wrong with them. And students engage very quickly at identifying what's wrong with the game and wanting to change the rules to make it different according to their own criteria. So the problems around my talk, the problem situation is that computational thinking, programming, and mathematics are still quite fragmented, and they have different kinds of communities behind them. And we have at the level of curricula, the level of educational systems, we have sudden sparks demanding that these three things get fused in some kind of way, demanding, for instance, that there's a programming element in mathematics curricula. And there's no explicitness, there's no elaboration on exactly what to do for teachers. Teachers get kind of confused. Am I supposed to learn programming and add it on to an already very heavy curriculum? Am I supposed to find a way in which programming has some connection with mathematics? And what's in it for the mathematics curriculum? What's in it for my job to help my students understand the mathematical ideas? Is programming just a help? Is it an obligation, and my task is to make sure that there is some mathematics learned as well? What is the situation? And I've seen this not only in Greece, but also in Sweden, where I'm working at Linnell's University. There's a lot of effort in trying to find ways to merge programming and mathematics. What I'm particularly focusing on is an idea firstly coined by Richard Noss and Celia Hoyles, the idea of using mathematics, putting mathematics to use, using them to create things or using them to negotiate over the creation of things, and also engaging in practices involving soft skills, not just mathematical skills, but also other kinds of skills that are like a frame for mathematical meaning to generate. So also I'll be talking about students who start from something to change, something to bake, which is either designed by somebody else, their teacher, or maybe not. Maybe it's designed by them. It's a first attempt at something, but they understand that it's a first attempt and they address the model as something to be changed. And also the activity of tinkering, where you have an artifact, you engage in changing the artifact, but there is not a big thing at stake. So it's okay to continue tinkering and to continue expressing meanings and trying to create things with the artifact by changing it, which sometimes may be surprising. Sharing what is going on and discussing over it. And also with digital media, we have the use of linked representations. So for the same thing, you engage in using diverse representations that are dependent on each other. And that we have found often helps in students dissociating from the representation and thinking about the concepts themselves. So today we'll talk about the craft of designing faulty models, the craft of designing half-baked models. There's a lot more detail in this, and it's a lot more interesting than it shows at the beginning. And for any model, however simple it is, think of a square, we'll see in a moment. There are 1001 different ways of half-baking it. And with each way, students stumble on different kinds of mathematics and deal with different aspects of the same concepts. Also, what is the challenge of baking? If you are a student and you see a model, you don't know where the problem is, if there is just one problem or more than one problems, how it is expressed, what you need to change to resolve it. So that is an interesting and quite particular, distinct activity in itself with respect to programming and mathematics. We're also going to talk about resources, and I will explain the influence I have had from our French colleagues and the idea of resources and addressing teachers' work and students through the artifacts that they make and what they mean to them. So I'll talk about three kinds of resources: microworlds, that are places for students to explore relatively freely; micro experiments, that are experiments that are more specific in the questions they place, but they also have an open question to engage in exploration; and scenarios, that are activity plans, structured activity plans designed and written from teachers, addressed to teachers, and like they operate in teacher communities to discuss over pedagogical issues. I'm also going to be addressing these issues through two diverse authoring systems. The reason why I'm focusing on these is that they are available for anybody, and they are in English, and any one of you can use them to develop your own stuff for your students or play with them yourself. And I'll be engaging in two parts of my talk with using the tools themselves myself, so you get a sense of how they work, and try and say some things through using both of them. Malt is like malt whiskey. That was the idea. It's Machine Lab Turtle Worlds. That's what it stands for. It's an authoring system which is a turtle geometry logo programming system, but it has two distinct aspects that in conjunction, I haven't seen another system like that before. One of them is that it has dynamic manipulation of values of variables to procedures. So you can write a procedure, execute it with some specific values, and then you can see it dynamically manipulated as the values change. And secondly, it's three-dimensional, so you can start thinking about building things in space. Choico is very different, and it's different with respect to the paradigm it affords of mathematics education. It can be used for situations where mathematics is not at the center. What is at the center is large socio-scientific issues. Michelle's talk was about such issues a fortnight ago, and it's a game where students create games based on the idea of choices with consequences by the player, and they embed mathematical ideas by thinking about designing and creating the kinds of consequences each choice has. So I'll show you what this is all about. So before today's talk, therefore, I'll introduce the Educational Technology Lab very shortly to see where I'm coming from Greece. And then we'll have the first batch of showing you the two tools, the kind of things they can do, so you can get a sense of the actual artifacts and how they can be used. And then we'll get into the theoretical framework which we use here in Athens to think with and to discuss and analyze what our teachers and students do with these tools, based on the idea of engineering mathematics. This is what we call the mathematics put in use in order to tinker with digital models. Then I'll give you another short introduction, because you will have the PowerPoint to look at it in more detail, and the URLs about the Greek contexts where all this is happening. It's happening at small scale as a result of the work of a research lab, but also at large scale, having had the opportunity to influence the infrastructure from the Ministry of Education on the uses of digital media for years 3 to 11. And then after that, I'll get into the main part and talk about what people are doing with those tools, get into detail about what we mean about engineering mathematics, what we mean about the art of half baking, and this new acronym. I know it's not in very good taste, and it's not. I don't mean for it to remain in posterity, but it's the YouTube activity model with these kind of tools. It's a model where students either engage in unplanned activity, or they engage in setting a task and trying to resolve it, or trying to bake a half-baked model, or combining the three things we just said into an activity where they bake models and then they use them as units to engage in more freehand exploration. And we'll end up with discussing the value of integration for our constructionist community, integrating different theories, integrating affordances in tools, and developing a more elaborate language to converse and to communicate with the outside world on issues about education. So where do we come from? Well, this is just, it's a research lab. It's positioned at the School of Philosophy at the National Kapodistrian University of Athens. And it's in a place which is about education. So we collaborate very closely with the math department, but also we have a lot of students who are teachers from outside mathematics, engaging in constructionist tools. Sometimes they have mathematics embedded, and sometimes that's not so necessary. They construct other things. We've been involved in European research projects. R&D is research and development. These are projects that in Europe are typically designed to bring different research groups together. So each project involves 6 to 8 different universities collaborating to do one large thing. We have to think in large frames to do research. These are some of the projects we've been engaged in. I'd like to draw your attention to the Kaleidoscope. Kaleidoscope was a very large network of excellence. Some of you may have been involved. Celia and Richard were certainly involved. Richard was one of the founding members. And there the idea was to integrate the different fields addressing the future of learning with digital technologies. TELMA was Technology Enhanced Learning of Mathematics, a group within Kaleidoscope that started work, which was completed by a consecutive program, a subsequent project, which we called REMATH, Representing Mathematics. Michel Artic has often referred to it, and it was a project where we tried experientially to connect different theories about learning mathematics with digital technologies by developing digital tools, and also by cross-analysis, by taking each other's tools and carrying out a piece of research and then discussing what happened. Also MC Squared, it's Mathematical Creativity Squared, was a project about teachers. Paul Drivers was engaged, Luc Truche and the Lyon team were engaged, the Knowledge Lab team were engaged, and a team from Barcelona as well. And we looked at how to spark creativity amongst teachers designing digital artifacts by getting teachers from different disciplines to work together to develop scenarios and to develop microworlds. Within our lab, we've been at the center of designing different kinds of technologies. Malt and Choico are the recent ones, where we are following a sustainability model that makes them web-based and available and workable on phones, on any kind of device. Anything you create with these two tools can be downloaded in the form of a file, and then so that then you can use it again by uploading it and making changes. And Digital School is an infrastructure from the Ministry of Education. I'll show you what I mean by that. It's a place where there's a very large number of artifacts, and Malt and Choico artifacts lie within this kind of conglomerate of different kinds of things available to everybody. So we've been participating in these large initiatives, the Teacher Education Initiative and the Digital School Infrastructure, and basically involved in design research, designing classroom interventions with these tools and activities, and working with teachers and trying to figure out what goes on, what kind of meanings are generated, what kind of interactions and relations between teachers and students, and between students themselves. And we've also worked with teachers in teacher education contexts. There's a lot of people, maybe I'm forgetting someone as per usual. This has become a joke. There's always somebody I forget to say. The recent group members, Nicoleta, Katerina, Maria, Stefanos, Kostas, Fotini have already obtained their PhDs, and we're still collaborating with them. Our other colleagues are engaged in PhD work, but everybody's working around these different issues, so it's not just myself. The projects I mentioned about, I'm just putting them on a slide here in case you want to visit them later when you look at the video, which will become available. Also, the tools are available. Just click and join in. And now I'd like to show you about the tools. So we'll switch into just a browser, and we'll do nothing. We'll just get into Malt from the beginning. You just type Malt2. It's very easy. Comes up first. And you get into the piece of software. I hope you can all see. One of the easy ways to see what it does is to look at some examples. These are some projects that I use to show what it does. So I'll just go into the dancing pentagons. It's an easy way to show, especially for people who know a little bit about Logo. What is this? This is a relatively succinct, simple, but not so simple program which draws these pentagons. It's based on this unit, which is just a pentagon, repeat 5, and the turn is 72 to make 360. And then there's a little recursive program that draws one pentagon after the other with a factor of 0.75 reduction of the length of the side. Okay, so when I execute the pentagon, here it is. It draws this kind of figure if I have these values to the variables. And then with Malt, I can take my cursor and click on any point on the trace of anything I've written. And when I do that, I get an activation of the variation tool, just here. Variation tool understands which procedure this thing was built with. So it knows that this procedure has 5 variables, and this is the number with which we executed this particular instance, the pentagon procedure. So if I move my mouse, drag the mouse, I can see what happens as the value of the procedure changes. So this is like re-executing the procedure, but very quickly. So I see what happens. Nothing interesting, it's just the size of the whole thing. But if I change the number of pentagons, I can see that I have less, which is still not particularly interesting, but you can see what it does. When it starts becoming interesting is when I start changing a turn that I have placed after the end of each pentagon. So you see that already now I have figure which is not so trivial, and by dragging I start thinking about why does it work like this? How does it behave? I think about behaviors. What kind of problems can I think of that might be interesting to resolve? What kind of forms does it take? And in the same way, I have another 2 turns. I can see this in space. So at the moment it's on a plane, and things are moving on a plane, but they can move on a different plane as well. This one. So this is just a turn around the bird's axis. And this is around the other axis, the one perpendicular to the screen. Okay, and if I want, I can click on 2 axes for 2 variables, and I can see a kind of a change of 2 variables at the same time. So up until now, this is just what it does. I wasn't meaning to show anything further than that. But if I just type a little procedure here, by the way, you execute commands by pressing the insert button. So I press insert, and I see this procedure called curved. You can see the code here. If anybody is familiar with Logo, maybe you can quickly see what it does. It's a little bit strange, and it looks like a square to begin with. And if I move the length, then you can say, well, no, it's not really a square. It might be a rectangle. But then look at what happens now. Let me just say 0 to 360. If I move the other variable, I can see that, in fact, how was this constructed? It was constructed by, well, you could say, by building a rectangle. Only two of the opposite sides are arcs. They are curves rather than segments on a plane. And I can think of this artifact as a definition of a cylinder, maybe. And so this is the height of the cylinder. So a cylinder is the object that is produced by defining a rectangle, but having the two opposite sides as curves. Why am I showing you this? Well, because with this tool, it's very intriguing to think about mathematics in a different way. Think about mathematics that can become accessible to students that were not so accessible before, and about 3D objects coming alive, and thinking about them in different ways than the ways that are classically defined through in curricula. Okay. Now, what about Choiko? Choiko is the same thing. I just type Choiko and it comes up. Here it is. I have a game already open to show you, even though you could start from scratch if you wanted. As usual, game is here. There. So it says, let's play, fine. There's no other instructions. So what's the game about? If I take the role of the player, I have different choices to make. I can, for instance, eat a bag of salty crisps. Salty, not sati. So if I eat a bag of salty crisps, there'll be consequences on two values. One is the liability of me getting diabetes. The other one is sheer pleasure. And the consequences that are being put in the game is that there will be an increase in the liability of getting diabetes, and there will also be an increase at the level of pleasure I have. So even though these two are positive numbers, the first value, having a positive number, is a negative consequence. Second value is positive. So if I click select point, see I have diabetes liability 1 and 10 in my portfolio. If I click, I get changes. And if I keep eating a bag of salty crisps, sooner or later, I'll be thrown out of the game because it's not good for me. Yeah, the game has ended. Bye-bye, it was nice knowing you. It wasn't a very good idea for me to continue eating these things. So what happens with this game? Everything that you saw is changeable, is authorable. If I like, I can add another value, another dish. Say, if I have some chocolate crisps and the cheesy pie, there's 3 things that are not very good for you. Broccoli and the beef steak are good for you. So if I want to have a third thing which is good for you, like say spinach pie, and then put some values in there arbitrarily. Diabetes liability, well, it's minus 3 because spinach is good. sheer pleasure. If you don't like spinach, some of you may like spinach. So, you know, this is already a value-laden issue. So sheer pleasure, I could put also -5 if it's not very pleasurable. And I can also add a value. What value could be interesting to add? For instance, weight gain. And I could put values on that. If I eat chocolate, yes, I'm going to gain. If I eat broccoli, no, I'm going to lose weight. Bag of salty crisps, and I'm going to put on a lot of weight. Beefsteak, well, maybe nothing. Cheesy pie, yes. And spinach pie, no, I will lose weight. Okay, so this was a kind of data handling part of the computational thinking I need to engage in to change my game. And I can change the picture here too as well. And then I have some programming that I can do. I have a Blockly language, and these are the initial settings. So I need to, for instance, add something about the third value I've just put in, the weight gain, set the field gain to 0. And I have the end rules, where things happen if you cross over some red lines. So I can choose to put another conditional here, and say that if your weight gain is, for instance, larger than, if you get more than 10 kilos, you're out. So what you need to do, you need to take an action, like put a pop-up window and say bye-bye, overweight. Too overweight to play this game. And then I can have, for the game flow, I can say game over. So I put in a little rule. And now if I go back and I play, might take a little time to go back, I will see that my game has changed and is has got a different value. So this is the way that I can change, I can do game modding, so I can bake a game which is not ready yet. By inserting some values, I can think of embedding mathematical ideas, but they are embedded in wider issues. This one has to do with nutrition, it could have to do with environmental thinking, or it could have to do with money management or whatever. So these are the two tools. Let's go now back into the PowerPoint. How much time have I got?
You have another 20 minutes about.
Okay, so now what kind of theories do we use, and do we try and elaborate on to think about the kinds of mathematics done while students are correcting games, or they are changing different artifacts? Well, first of all, Richard and Celia's idea of meaning making, and Seymour Papert's as well, in contrast to thinking about mathematics with respect to how wanting students are, or the kind of misconceptions, or how much students fall short of the mathematics we would like them to be able to do if they were all mathematicians. It's very Papert's idea, and which was elaborated by Celia and Richard, was that students do engage in mathematics. Their thinking is mathematical, and it's very both interesting and important for us to understand the kind of logic and the kind of rationale students use, and the ways in which they put the mathematical ideas to use in order to be able to help them generalize and find different connections between the ideas and the abstract way that they are presented in curricula. But what is also important with digital media, and this is some work also I did with Candia Morgan at the Knowledge Lab that inspired me to engage a little more in this, is that we can think of digital media as semiotic media, as one more representation that we use in a set of representations that we already use, and what kind of connections we make, and how we use all these representations in conjunction with each other. So it's not just programming, but it's programming added onto the way that we talk about mathematics, on the way we formalize mathematics, on the way that we use our gestures to communicate mathematical ideas, and the ways that we represent mathematics graphically. And also the French group, the French school of thought, have elaborated a different perspective on both teachers and students' activity, that they look at everything that they do and the understandings that they develop and their professional itineraries through the way in which they design and produce different kinds of resources, and the ways in which the kind of things these resources mean to them, what they represent, the meanings. They use Vergniaud's word schema, theories in action, to express that the instruments we use, we develop different kinds of meanings about these instruments, and these meanings are distinctive to each of us. So they study teachers as they design and develop resources, as they use them in the classroom, as they redesign them, and as they use them in professional development context to discuss about educational ideas. And they also look at students' mathematical activity through the students' engagement with resources and the students' own development and change of resources. And it's an interesting perspective to think about programming mathematics and engineering mathematics, and there's a lot more elaboration to be done there. And the last framework that we found very useful was the idea of to look at artifacts as boundary objects. It was Celia who brought this idea into the math education community, and it's becoming more and more prevalent in our work, that we can think of artifacts as objects over which people cross boundaries. They come out of the way that they see things through their own perspective and try and understand and communicate with the ways other people see the same object through their perspective. And so why do we talk about integration of ideas? Well, the constructionist community is a little insular, and it's I think that there is a lot more to the ways in which constructionism can be put into use, not only for us to understand teachers and students' work, but also to be able to mobilize and make use of different theoretical frames that have been developed and that describe more succinctly different aspects of the situation of using digital media. We found it quite important. We were influenced by the Remath project and by Michel Artigue's work, but from then on, we've been engaged in this. The other slide I wanted to show you was some powerful ideas with respect to designing artifacts. These two are ideas that come from very different places. The idea of conceptual fields came from Paris, from Gérard Vergniaud, to think about concepts, mathematical concepts, not in isolation, but in connection with concepts that are very close to them in connection with different representations and in connection with different kinds of exercises or different kind of problems where these concepts are important. So Vergniaud says, do not look at concepts, look at conceptual fields, and each time consider the situation in which these concepts are used. We use the term restructurations in different ways, in a little different way than Uri Vilensky and Seymour Papert. We see it as a way with which mathematics teachers and teacher educators can feel a little freer with respect to curriculum to look at and question the structure of mathematics, which was designed and made stable about 250 years ago when we didn't have digital media, and think about mathematical fields that can now be very, very good tools for students to generate mathematical meanings now that we have these representations. Some examples we've worked with at the lab are, for instance, curvature. Curvature doesn't lie in a particular section in any math curricula. You can find it in different contexts and in different kinds of sections. But if you think about digital media and about programming and dynamic media, dynamic manipulation, there may be some argument for thinking about thinking about the curvature as a unit, as a mathematical idea over which students can work with covariation, with geometry, with curves in geometry, curves in space, and with trigonometry. Another such idea is that we work into now with my student Mirto, is on can't find the word, periodicity, and trigonometry, and how the idea of periodicity is involved and apparent in many different mathematical ideas, even the idea of angle or turn. The concept of half-baked artifacts, which addresses the paradigm, epistemological paradigm of fallibility in mathematics. Mathematics is a science where everything is positivistic. You're supposed to know and be certain about certain things through mathematical proof. But also there's a lot of activity in mathematics which is about questioning, about refuting. Some of you may know a wonderful book by Hungarian mathematician Imre Lakatos, Proofs and Refutations, where he describes mathematical activity as mainly an activity of trying to refute somebody else's mathematics, and much less as an activity on being certain about everything. So that's what's behind half-baked artifacts, to help students get into the practice, into the mindset of questioning the properties and the mathematics with which these artifacts are being built. And also the idea of that the mathematics itself changes within the process of working within a tool. Both mathematics is shaped and the tool itself changes. With respect to teachers, we consider teachers as designers, and we've used Diane Lorilard's idea, of course, where she talks about the teaching profession as a design profession, and says that it makes sense to look at it like that. But also on collaborative designs, there are theories that have to do with groups of people communicating and together designing digital artifacts. Fisher has called these groups socio-technical environments. Marcelo Borba and Monica Villarreal discuss the idea of humans with media, how these things fuse together, and groups of people find themselves in situations where they reorganize their thinking as a result of being part in different groups. In MC Square, we looked at another idea, the idea of communities of interest, not communities of practice. A community of interest is a community of people, participators who collaborate, and they have a target, they have a joint enterprise and a joint goal, but these people come from diverse fields, so they have to communicate and develop creative ideas by crossing boundaries and by understanding each other and establishing a means of communication in order to do this. And finally, black and white designs. These are designs that are not like Scratch or like Logo or like these tools where students are supposed to develop everything from scratch, but they are designs where a part of the artifact or a part of the tool that you provide users with is black box, because you don't want them to engage with every little detail, and part of it is transparent. Part of it allows them to look inside and to make changes, etc. And this black and white perspective has permeated all our designs, not only with technologies, but also with the microworlds and in education. The art of figuring out what to hide and what to show to students in an artifact or in a structure. So I wanted to briefly go back into the tools and show you some instances of these tools being used by others. First of all, take a look at the digital school. Yeah. This is the actual site of the ministry. You can imagine with the with coronavirus, it's taken a lot of a huge increase in use. Where I'm going into is a portal that has a lot of artifacts. And if I go into mathematics, don't worry about the Greek, I'm going into mathematics now. For instance, going into year 7, there it is. And I get into what they call interactive books. Now, interactive books is just a curriculum book. So this curriculum book digitized, but as you see, it has links, which are called micro experiments. And each of these links has been designed by a team of teachers and educationalists to make mathematics come alive. So this is, I've just chosen a little section on parallelograms. If you click on a micro experiment, what happens is you get into Malt directly, and it's the programming language, it's the tool. You can use it for anything, but this time, this is a micro experiment. There's a little blurb here that says that Nick tried to make a parallelogram, and he wrote this program and then executed it with these commands, and it came out faulty. Can you help him resolve the issue? So what happens here is that this parallelogram has got 2 constant values for the opposite sides, but it has no relationship. There is no functional relationship between the turns of the turtle, and this is why it looks jagged and it's not right. And students can, in the same way as before, they can experiment to try and figure out what's going on, and then to go back into the code and try to fix it by putting the functional relationship of the 2 consecutive subsequent turns that they have sum of 180 degrees. Now, what you've just seen is there's a lot of micro experiments. There's about 1,800 micro experiments in year 3 to 11 in the curriculum books. And it's a different way to think about a portal. So it's not just a portal of artifacts that you can look into it with search with keywords, search keywords. But it's the actual book you can go and read, and then you can make things come alive at the place where you're actually reading about the mathematics. It's a different way of thinking about gathering artifacts and making them available. So let me get to an example. For instance, this is hidden behind the stop share screen. Oh, what have I done? Right. Share screen again. Share, yes. Where am I? Yeah, no, I wanted to go into this. A little bit about meaning generation. These are students who decided to make a pizza. And this kind of toolbar with all the faces gets in the way all the time. It's very funny. Let me just show you. I'll skip the context stuff because you can have access to it when you look at the PowerPoint. Now, when we talk about engineering mathematics, what do we mean? Here, this is two examples. Look at the first example. Our teacher told us to construct a castle using variable. Variables are some letters which represent whichever numbers we want. E.g., we make a square with an A side, and in this way we can save time because we can put whichever value we want in a variable, which means we can make however many different squares or even rectangles we want. This is, in my view, a very deep understanding of the idea of generalized number and variable, but it is situated, to use Celia and Richard's term, it's situated in a case where students were engineering something. They wanted to build a model of a castle. So the way that they explain it is very deeply mathematical. So variables are some letters. So these are the symbols which represent, the letters represent something, and they represent whichever number we want. I think this is key. So meaning that it doesn't matter which numbers will take the place of these letters. We can, if I have the letter and if I have the variable, then I can think of any number, and whenever I want, I can replace it with a number. I think that's very important, considering that these students are in year 6, so they're still primary education. It's quite an advanced way of discussing the idea of variables, which was generated through this. And the second pizza example is students now in year 7 who were working with circles. And then they came up with their own problem to try and create a pizza. So their first line of code was just to do the segment forward X, then turn right 90, then put some code for a curve, and then turn right 90 again and forward X like symmetrically. And they realized that this code was not correct and they should fix it. So they said, let's see what the problem is. If you want to see in Malt, this is the situation. And if I just, two bars in a way again, this is the pizza program. Right, so this is why it was faulty. And if I manipulate it, I quickly see that n, which is the size of the curve, doesn't matter very much. What matters is the length of the segments, or the turn while it's doing the square, while it's doing the curve, sorry. to make it smoother. So they were doing these kind of experimentations to try and figure out which of the three variables are important and what's going on. And what they started to do in this attempt was they tried to well, first of all, they tried to change the size. This example, we were arguing a lot over it and trying to analyze it with Dimitri, who's another one of my PhD students who's now completing his PhD, and it was very interesting to see the mathematics that was generated while the students were working. So n just changes the size. They realized the position and the value of n in this three variable procedure. And then they said, well, what happens if we change the value of x? So they use the slider again. And then they see that if they multiply a value of x with the value of turn in the curve, they get a number. And that number was 56. And then when they use a different value of x and they multiply it with the value of turn while doing the curve and wait and do it until there's a pizza shape, they see a value of 58, which was close to 56. So they thought, let's do it again. So this is the kind of experimentation of pattern recognition, where they see that there was 56, 57, 58, and then somebody said, well, it should be 57 because that's in the middle. And then look at this, it says, well, I don't know. Try it again. Why is it 57? So this is a kind of questioning the mathematics, trying to refute the idea that it's 57 because it was the middle value of three values that they made in their experiments. So they put 57 in and drew a whole circle. And when they drew the whole circle, they realized that the segment that they had developed was a radius, because the second segment came and coincided with the first. And then they said, well, maybe this is the length of the radius, and it has something to do with something that they knew from geometry. So now they came up with that, with the formula. And then they said, how can we use it in the program? So do you see this kind of going back and forth from the mathematics in use, questioning mathematics, putting mathematics in use, realizing that there must be something from the curriculum which might be useful here, and then reconsidering how can we put this mathematics from the curriculum in use. And this was a kind of a mesh of using the sliders, using the dynamic manipulation, and looking at the code, looking at the formalization. So then they figured out that, well, it's since x times q is 57.32, because this is how much 360 divided by 2 pi is 57.32. So now we know, and we have the certainty, then q is a function of x. So what they did to correct the procedure was to eliminate one of the variables. And this is a kind of a backward process where they insert a variable to make an experimentation, but then when they find that there's some functional relationship between two variables, they are free to eliminate one of the variables because it works in this kind of way. This is the kind of engineering mathematics that I'm talking about. I don't know if I made it quite, if I was clear of the kind of the process, because it's always very difficult to describe it. 0 minutes. Is that a 0? Or is that an O, letter O?
It is 0.
Okay, so I'll finish off. There's an equivalent thing with Choiko that I was going to show you, but that's okay. I'll finish off with these slides that we are discussing about engineering mathematics, the mathematical definition of a concept in an engineering setting. This is in the frame of computational thinking and programming. We're working with Marianthi, another PhD student of mine, on the idea of computational thinking and programming, and how these two, we need to fuse them. And then about the idea of half-baking and of different kinds of activity with these half-baked artifacts. If I had another 45 minutes, I might have got to the end of the slides, but the slides will be there after the talk, so you can look them up. So thank you very much.
Thank you so much, Dr. Kynigos. Well, you presented us with a wide variety of baked, half-baked experiences that students have engaged with, that you've engaged with your graduate students in developing the experiences and environments. So there's such a wealth. There's just so much that you presented us that opens up so many questions and so many opportunities for discussion. So what we're going to do is open it up for discussion, for any questions, first of all, from the panel members, and then we'll open it up to any other attendees. So for those who are on the panel, if you have a question, you could turn your microphone on and ask a question or make a comment.
I think I have a question.
Go ahead.
Sure.
So first of all, Dr. Kynigos, thank you for sharing these like very inspiring ideas. I think those are very rich and deep ideas. Actually, it was the first time that I saw codes in Greek, and I found very interesting the issue on syntax and so on. But I think I have two questions. The first question is, you mentioned that Choico is part of a different paradigm. So could you please elaborate a little bit more about that and the reasons why Choico is part of a different paradigm? And the second question is, you mentioned like the large scale experiences. So those numbers are very impressive. 14,000 teachers and almost 2,000 micro experiments. And regarding that, I think my question is, where's the impact of these tools like Multi2 and Choico on teachers' experiences in terms of assessment and evaluation? Thank you.
Yeah, sure. Well, with respect to your first question, Choico is a game. Okay, it's a game designer piece of software, and the kind of games that you can develop with Choico are games that are around what we call socio-scientific issues. So in this perspective, we have what we call post-normal science epistemology, where we don't have the sciences as mechanisms within human culture through which we find the truth, or we are positive or certain, or we look for the truth. Instead, we have large, complicated, gray area issues over which we don't know the solution to, like the climate change or sustainability issues or diet issues. And our everyday life is filled with them. We need to grapple with these issues. We will never get a resolution, but it's important to have ways of thinking about them, ways of understanding them, ways of dealing with them, and ways of finding micro solutions that have relevance to our everyday life. And in this process, you can use mathematical thinking, rational thinking, and mathematical concepts to help you grapple with these issues. And in that kind of way, it's It's a paradigm that situates mathematical thinking and mathematical concepts in a different role. It's not the end target. The objective here is not to find the ways to use mathematics in a situation where mathematics will resolve your problems. You use mathematics in a situation that will help you deal with those problems that will never disappear. And also they are contentious. I mean, people argue over them and they have different views and different stakes. There are different stakeholders. So you need to be able to have a mathematical kind of thinking to engage in a community that has a certain view of one of these social scientific problems. That's the rationale behind developing a tool which is so different to the ones that we are accustomed to. And we have a very, very large, up until now, variety of different games, very creative teachers and students. Some of them pick up games and change them in ways that surprise us, and in many different domains, which I don't have time to discuss. Now, with respect to the second part of your question, yes, this is indeed a very large scale, especially the teacher education scale project is been going on for more than 10 years now. Of course, it's not overnight. And it's project which has, it's orchestrated by the ministry. So it's kind of a service to everybody. So it's very hard to be able to carry out research that gives you precise information of how much these tools are being used, what kind of percentage of time these teachers assign to using digital media, how often they refer to these media when they carry out their courses. But what we do know is that they keep on taking the course, and that the parallel existence, the conjunction of the infrastructure with the professional development seems to be now picking up. There seem to be more and more people interested in designing activities and in getting the students to use these infrastructures. The digital school, there's this 1,800 micro experiments is only for mathematics, by the way. There's this different situation. I think there's over 7,000 artifacts in total. There's a lot of people behind this, developing them. And there's also a group that tests them from a technical point of view, a functionality point of view, all the time. So it's not just a portal that you put up things and then project finishes and you're done. It's a situation, it's an infrastructure which is placed within the ministry, and it's taken different kinds of administration, different administrations, and it's survived through them so far. Because each time we have a new administration, they realize that there is political value in building on this, finding something to build, of course, but in building in something which is already there. So it's an interesting experiment, what goes on in Greece. The reason I addressed it in this talk is to show that once you have web-based tools, you can think differently about ways in which they can be placed in larger situations, larger frames. So imagine Celia and Richard's curriculum was, it worked in, I think, year 6 and year 1 secondary, or year 5 and year 6, if I'm not mistaken. And there were 150 schools behind it. Imagine if there was some magical way in which this curriculum could appear in the ministry infrastructure in Canada, for instance, or in another country. We need to think in those terms and not in terms of developing things that we believe in and then letting everybody find out how good they are. But we need to go out there and position ourselves in situations where there are different views and different perspectives.
Thank you very much, Ricardo, for your question. That was Ricardo Scacuglia from Brazil, UNESCO. And Chronis, thank you very much for elaborating on that. Is there another question from someone on the panel?
I just have a quick comment.
Krista, Francis, go ahead, please.
Yes, I just wanted to say thank you. I love this idea of finding mistakes in the code, because that takes a considerable level of skill and awareness of coding. So I think I'm going to borrow on that idea in my future practices. Thank you for that. And I really enjoyed your presentation.
Thank you very much. It's really challenging, the craft of half baking. So the idea of which part of the code to tamper with as a teacher, and what do we mean by taking away a property, or what do we mean by putting in a bug, which bug and what kind of bug, and in how many places. And there's every time I teach the course to my at the master's courses, I find myself going one more step in detail in different ways in which you can half bake an artifact. It's quite fascinating.
I appreciate that. And it would be kind of an analysis of common errors too, wouldn't it? To find where people commonly make their errors coding.
Yeah. Anyway, this is described succinctly, because there wasn't much space, in a book that's coming out about constructionism. It's called Constructionism in Context. It's at MIT Press. It's going to come out in the fall. And there's a lot of very different papers in there. So there'll be a lot of stuff.
Thank you, Krista. Reminds me, I probably misremember the author, but I think it was Triandafylos Triandafylidis, who wrote a paper almost some time ago on mathematical lies, where he engaged students in telling mathematical lies. Now, of course, if I tell you that 5 + 5 is 1,000,000, it's not a good lie, because right away you know it's wrong. So how do you tell a good lie? So in a sense, it seems like to be the same kind of issue. How do you half bake well, you know,
yeah,
so that it leads somewhere.
Somewhere productive, yeah.
By
the way, these are 3 master's courses I'm engaged in. Just wanted to put the slide up. As you see, one is in Sweden, and we have a very nice collaboration with our group there, Marcelo Milrad and his colleagues.
Thank you. Any other comments or questions from the panel? Looking at our chat, we have Christian Mercat from Lyon, France. And Christian, you can go ahead and ask your question if you like. It's written, but if you like to state it.
Okay. Thank you very much. So it was a very interesting. Do you hear me? Yes?
Yes. Yes, yes.
Okay. So it's simply that these half-baked situations are difficult to craft. Okay, so this I understand perfectly. But once they are crafted, don't they require superpower from the part of the teacher in order for it not to go astray? I mean, is it possible to pass on to layman teacher without very deep epistemological background this situation, and is an everyday teacher able to steer it the right way? Thank you very much.
Yeah, well, it's all in it's all in this craft idea. There are ways to half bake an artifact where it's quite obvious for a teacher who is not so much engaged in this idea, and there are ways to do it. I don't know if you saw this, you noticed this micro experiment that I showed you from the digital school infrastructure don't know if I can find it now, but anyway, where there was a story behind that. There was this student who was trying to create a square or a rectangle, and he didn't manage it, and there was something faulty, and can you help him solve it, etc. This was particularly designed so there was just one simple fault, bug, and it's obvious for the students to see and for a teacher who's not so much engaged in this to understand what's going on. So there are ways to simplify the task so that you can address teachers who have not gone through a master's course or not gone through these kind of courses. And as you can understand, when we're talking about the Ministry of Education, it's a very big responsibility. We couldn't have made 1,800 micro experiments that demand teachers to have a PhD in math education to resolve. We needed to find micro experiments that were easily understood, even by the teachers who had not done any training yet, as a default. But in each micro experiment, we had an open question at the end of it, which was optional, of course, and that was addressed to teachers who had taken courses like that. And I mean, that was our strategy, and there are different kinds of ways to do it.
Thank you, Christian. We have a question from Jesus Enrique. Could you please go ahead and ask your question?
Okay. Hello.
Hello.
Good morning. I'm Enrique. Actually, I'm from Mexico, currently at the postdoc at the University of Calgary. But I have a quick question, I think, and it's about the computational thinking and programming concepts and practices. Particularly, this slide took my attention, and you didn't talk about this, how these computational thinking concepts and practices fit with this idea of the half-baked. Particularly, there is a practice that took my attention, that is classification, that is not from coils and nodes, for example. I would like if you can elaborate something like about that. Thank you so much.
I'm very glad you noticed that. This is our secret. This is our next kind of task, to develop a new authoring system to help students engage with the idea of classification, because we feel that it's one of the very important ideas that has not been noticed very much so far, and it's very much tied to computational thinking, but not only. It's also mathematical thinking. The idea to the task to identify categories of things, to be able to create structures and nested structures in large sets of data. And Michelle talked about narrative, about stories, data stories last week. That we are, we are showered with such a large number of data. It's very important for us to be able to understand the classifications that others make of these data, the way that the classifications are presented to us, and to rethink and question these classifications about where things belong. And it's a complex issue. But more generally, your question about computational thinking, yes, I mean, its proponents like Wing, etc., at the beginning opted to separate these two aspects of computational thinking, separate the concepts from the practices, mainly in order to highlight the idea of practices around computational thinking, that they are important, and that computational thinking is not only about learning about the concepts, for instance, of programming or data handling, etc. And these practices are not just a set of practices, but it's also a mindset, ways in which digital citizens will need to think in the future of how to understand the tools that they use and the new kinds of activities, the new kinds of collectives that these technologies place them in, and how they can operate, how they can converse, how they can think and work with others or by themselves in these new situations. So there's always an argument about what exactly are those practices and which ones are there. Are there 3 practices, 4 practices, 5, and how do we define them? But there may be new ones, or there may be new ways of viewing which are the practices. The main idea is the mindset, and how we can help younger people who are more engaged with technology than we are, how we can help them engage with technology in a more productive way than what is designed for them. Yeah, and having said that, we now need to connect computational thinking with mathematics and with the production, with the engineering kind of mathematics. So that is another task in itself. And as I said at the beginning of my talk, I'm amazed about how fragmented people are and the institutions about computational thinking in mathematics. This was the first idea of how to use technology in education for learning that came up in the middle of the 70s, at the end of the 60s. And it's this very idea that now, so many years later, is still fragmented. What has programming got to do with computational technology? And what has programming got to do with mathematics? So we need to do something. We need to develop a better language to describe the connection and to make better connections, maybe in more detail, like the curriculum that Celia and Richard have developed.
Thank you. Thank you so much. Thank you for your talk. It was great.
Thank you.
Thank you, Dr. Kynigos. So we come close to the end of our session. I don't see any more questions coming up at the moment. I'd like to give you an opportunity to, I want to thank you for the wealth of ideas, resources, artifacts, and also things that are available online for us to access. I look forward to investigating some of these myself and also with my students. So I really thank you for that. Before we pass it on to Chantal, I'll give you an opportunity if you wanted to make any final statements or say anything else that comes to mind.
No, that's fine. Thank you very much for attending. And as you saw, the talk was about more like the ways that we are thinking at the lab these days and the kind of things that we are engaged in. So it's more like a talk to generate discussion, generate new ideas, rather than a talk about something which is being completed or finished. So I'm very glad that the discussion already started, and I'll be very happy to converse and to collaborate with people who may want to use these tools in the future. So thanks.
Thank you. Chantal, over to you.
Thank you. Okay, so thank you again, Chronis Kynigos, for this very rich idea, these very rich ideas that you presented to us. And as you say, it was to prompt some discussion. So there's a lot of food here to think about for a rich discussion. So thank you very much again. I thank all the attendees as well who came to the presentations and the ones that are right now watching this recorded seminar. I invite everyone to look at the website to see more information about the upcoming seminars. Our next one is on August 14. There will be Ricardo Scuculia from Brazil, who will be presenting on computational thinking and humans with media, blocks, fractals, and music. So everyone, thank you again for being here today with us, et on se voit dans 2 semaines. Au revoir à tous.